Okay, now moving on to the next two examples, and I just have to add, because I forgot our units, 60 kilometers per hour. Then we're going to go on to a second example here. The cost of ice cream cones varies directly with the number of cones purchased. 5 cones costs $20, and then we need to find an equation relating cost C with the number of cones N. So if you remember at the beginning, we saw that for direct variation, and this is direct variation here, varies directly, if we're finding an equation, it's going to have the form y equals mx. Now in this case, it's interesting, they've asked to use c and n instead of y and x. So cost of ice cream is at the beginning of the sentence, so that's going to be dependent, which means it's sort of like the y value, but cost, they've asked us to use c. So instead of y, we'll put c here. And then at the end of the sentence, we have the number of cones. So that's going to be your independent variable. So that's like your x value. So instead of x, number of cones is going to be n. So we're creating an equation that looks like this. C equals mn. Now, the correct form for these equations is that you leave c and n as letters, but we have to actually find a value for m. So we're going to pull out the same formula that we used before. M equals y2 minus y1 over x2 minus x1. And because it varies directly, our first point, x1, y1, can be 0, 0. And our second point, x2, y2, can be 5 for the number of cones, which is our independent, and then 20 for the cost, which is our dependent. Then we can sub in these values. So our y2 is 20, our y1 is 0, our x2 is 5, and our x1 is 0. So you'll get 20 over 5, which is 4. So we now know that m equals 4. So we can say, therefore, the equation for cost of ice cream is C equals, and then instead of mn, we worked out that m is 4, so we'll put 4n. And that will be our final answer. Okay, moving on to example 3. Ellen's pay varies directly with the number of hours she works. She earns $15 per hour. Complete the table of values, graph the relation, and find an equation that relates pay to hours worked. So here we'll actually get to see how these direct variations look on a graph. So Ellen's pay varies directly. We remember that direct variation always has 0, 0. So if we have 0 here, then we're going to have 0 here. After 1 hour, if she gets $15 an hour, she will have $15. After 2 hours, 2 times 15 is 30. And after 3 hours, 3 times 15 is 45. So $45. Pay, because it's at the beginning, is our dependent. So that will be on this axis here. And hours is our independent, so that'll be on this axis. So we have a point 0, 0. We'll graph it here. We have our point 115, which we can graph here. 230 here, and 345 here. And then you can just take a ruler and join up those points like this. And you'll notice that it's linear. Direct variation is always linear. So the last thing they ask us to do is find an equation that relates pay to hours worked. So for pay, I'm going to use the letter P. And for hours worked, I'm going to use T for time in hours. And this is in dollars. So we remember that our pay is at the beginning, so that's dependent. So we'll put that here. And then our time is independent, so we put that here. So we have P equals MT. And then we can take any of these points to find M. So M equals y2 minus y1 over x2 minus x1. So let's make 1, 0, 0 our first point and 1, 15 our second point. So then we'll get y2 is 15 minus y1 is 0. x2 is 1 minus x1 is 0. So you'll get 15 over 1, which is 15. And then, as your final answer, you can say, therefore, the equation for Ellen's pay is P equals 15, because we worked out the 15 was MT.